In this example, we're going to find critical numbers, and this time you can see that we are using a trig function. So our plan of attack is to find the derivative, set it equal to 0 or where it's undefined, and solve it. Okay, one of the most important things is that this is a chain rule that you may not see if you don't realize that this is the sign of x quantity squared. I mean, this is the way we write it in math, but this is really what it means. Okay, hopefully you guys can see now that it is in fact a chain rule. So I'm going to find the derivative by bringing the 2 down in front. The exponent turns into a 1, and then the derivative of sine is cosine. Okay, so I need to figure out when does 2 sine x cosine x, when does that equal 0? Okay, well, what you may not realize is that this is actually already factored for us. This is a product, right? And in fact, we could go ahead and divide by 2, and if I divided by 2, right, I would just get that sine x times cosine x equals 0. Okay, so here I have this product. It's already factored. So I want to know, when does the sine equal 0? And when does the cosine equal 0? Well, the bad news is it actually happens an infinite number of times, so we need to make sure that we account for all of them. So the sine will equal 0 at 0, pi, 2 pi, as well as the negatives. So a lot of times how we'll write this is we'll say x equals n pi, where n is any integer. Okay, so 0, 1, 2, -1, -2, -15, whatever it is. Okay, so all the multiples of pi, including 0. All right, what about the cosine? When does it equal 0? And the cosine equals 0 at all the pi halves. So pi halves, 3 pi halves, 5 pi halves, and then all the negatives of those as well. All right, this is odd pi halves. So how we typically write odd numbers is 2n plus 1 or 2n minus 1 pi divided by 2. Okay, so this is going to give me all the odd pi halves, both positive and negative. We should get them all. All right, if you don't feel comfortable writing this fancy notation, you can definitely just write a pattern, but make sure you put dot, dot, dots, because that lets us know that we've established the pattern is going to keep going. So over here, it would probably be better to write plus and minus, and then my dot, dot, dots right above. As long as you establish that pattern, we can know all the numbers that you're talking about. All right, so here is when cosine equals 0. Here is when sine equals 0. So that is all the critical numbers of this function.